push your thinking in new ways. So take a look at this first problem. We're going to do the first part together, then I'm going to shut up and get out of your way. So, today the whole day is calculator active. Okay. Read through the problem. I need problem 1, 2, 3, 4. You're the only one that's on a poster. Let region T be the portion of the xy plane which is bounded by the graphs of f of x, g of x, and the vertical line x equals 1. Region S is the portion of the xy plane which is bounded by the graphs of f of x, g of x, and the x-axis. Set up but do not evaluate integral expression which can be used to determine the following. Great. What didn't I give you?
The equation.
I didn't give you an equation. I didn't give you something you can type into the calculator. But instead I gave you the graph. I gave you a picture. So what you guys are going to do for A, we're not going to do D, that's only for BC students. For A through F, you're going to set up an integral expression for me. So, let's get some brave souls here. How are you going to find the area of region T? I see 1, 2, looks like 3, maybe 4, 5. Jonathan, what are your thoughts here?
Oh, you do the integral
Yep, we're definitely going to do an integral.
and pi. Oh, no, sorry.
Okay, right. Pi, we're going to reserve that for volume. I want area. How do you find area?
F of x minus g of x.
Why f of x minus g of x? You're right. Tell me why.
Because it's top minus the bottom.
Right? I want you to think about those little rectangles. Those little rectangles that we've been drawing forever. How tall? I heard you say f of x minus g of x, and I assume everybody's okay that this is f of x minus g of x. How tall? How wide?
Yeah.
dx, right? Whenever your rectangles are going this way, I want you to be like dx. And if they're going this way, dy. Okay, so top minus bottom dx. Great, there's, so f of x minus g of x dx. Knowing me, are we done? Ready to like move on? Why not?
Study them.
You still need endpoints. You need limits of integration. What are they? Edgar, what are they?
That point of intersection.
That point of intersection. What is this point of intersection?
A.
A. We're just going to call it A because you can't tell me what it is. So you're just going to say, I'm going to go from A to where?
1.
A to 1. Everybody okay? A to 1? We got this under control? All right, now let's mark this up because when we talk in a little bit, I want us to all look at the same thing. This point over here, I'm going to call it A comma B. So A is the X coordinate and the B is the Y coordinate. Let's look at some other points. This guy over here?
0, 0,
0, 0. This guy down here?
1,
1,
comma C.
1
Zero.
comma,
Zero.
1 all the way at the bottom.
0.
Oh.
0. This guy just above it?
1, comma C.
1 comma C, right? As long as we're calling it the same thing, that's what I care about. 1 comma C, this guy up here?
1, comma 1.
1 comma, maybe it's 1, I'm just going to call it D because
Oh. Okay.
it may not be 1. Remember, if at any point in your life you're like, ooh, I think it's 1, it looks like 1, those are bad feelings. Okay, so 10 minutes, go as far as you can. We've already done A. Everybody should be able to get B, C, and E under control. Super smarties, I want you to push all the way through to F, but B, C, and E, go for it. You guys know you can talk to each other and work with each other over here.
You have midpoint, you have midpoint. It's just the same thing.
You want to call it what?
They're just, because it's on top, there's still need teeth.
Careful, they're already.
And then this should equal 1/2 of the.
Still be on x minus just
Just that? Is that part?
12, 16, 19. Rambeer, Jennifer.
Abraham? What's
Abraham.
that?
No, but wait, I'll find out what that is.
That makes sense. Because 1/2 of the total. My head.
Yeah.
Oh. Seems correct. There's no gap, right?
How do you do B?
We got S.
No gap.
We got the S. It's a integral from A to K, that's minus equals integral from K to 1.
That has nothing to do with volume, right?
All right, real quick. Where are the folks that are still on part B? Okay, so I just want to talk to folks that are still on part B. Okay, part B, the location of a vertical line x equals k. Vertical line x equals k. So I'm just going to draw it somewhere. What's so special about this vertical line? What does it do? I only want to talk to the folks that are still on B. What's the thing that it does? It divides region T. How does it divide it?
2 equal parts.
2 equal parts. Last class, some folks were like, oh, it's the midpoint. No, 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 no. That's not what it says. What it says is that the area here equals the area here. So that means that if I'm calling this the point A comma B, then the integral from A to K, f of x minus g of x dx, what's so special about that area if I'm going to go from A to K?
It's equal.
It's equal to this guy over here, the integral from K to 1, f of x minus g of x dx. That's what's so special about K. The area before I get to the line, the area after I get to the line are equal to each other. Okay, if you're not sure about that, definitely talk to me now. This is a big idea, but everybody else keep going. Do part C, part E, part F.
What if I wrote it this way?
Yes, ma'am.
Oh, would it be wrong to
That's all
say
okay.
that the definite integral from A to K of f of x minus g of x dx is equal to 1/2 of the definite integral that you put at the top?
But then these two are.
Yeah, if it's only 2 equal.
No, I think you're
Like
right.
that is
yeah.
what I'm hearing? Is that equal to this?
Is that equation?
Yeah, right. It's an equivalent way to talk about it. You
Oh,
say
yeah.
the area before I get to the line equals the area after I leave the line, or the area I get to the line is equal to half the total. Great thoughts.
So that would still be fine, we'd still get points?
100%
Okay.
acceptable. 100%
That's what I was
acceptable.
gonna ask.
Good.
Don't you add it?
So you did the 1/2 of the original?
I got
You were-
pi
It's
of
some
integral 0 to a of f of x squared dx plus a to 1.
Wait, so it's pi 0 to a f of x squared d of x plus pi a to 1 d of x squared times d of x.
Yeah, his stomach.
How are you gonna do e if you don't know the equation? And then in the just replace x with y.
Oh, yeah. Because
Plus
this
one.
will be the space.
Yeah, that. No,
Minus 1.
Oh, minus one.
Right? It's a negative.
Yes.
I mean, it's positive. Negative.
plus one.
Is it plus one or is it?
Plus one, because.
Yeah, right?
And it will be under, so it's all minus five. One minus.
But what it,
Minus
so
one.
it's f of y and g of y.
Wait, did you?
It's a hollow G.
Oh, T, yeah, it's hollow.
Oh yeah.
It's half of it.
I'll just explain the b.
Should I just switch it?
So this one?
That's not my bad.
Why horizontal? Because it's here. So imagine this guy.
I was so close.
Yeah, I don't know what. She literally did it in front
The
of you.
big R is from the line that rotation and the graph.
So because this is an object, it's a three-dimensional object, it's going to be hollow.
So for little r is going to be
So you want to do a big R squared.
little r will just be this.
When you
And then big R will be that.
big R and little r, you start on the axis of rotation. You go down to the axis.
Yeah, because you're subtracting a little.
On the line y equals 1. You go down.
Right there. Are you done?
I think it'll be 1 minus of that square. Or would it be a like minus?
Yeah, for why, I guess I'm listening.
So y, two different intervals.
That's what I'm listening.
We did it the biggest thing.
Oh, yeah.
No, 1 minus.
It's like the height of the rectangle is what changes, right? Before the intersection, you're
No,
like, oh,
1
over here,
minus.
it's f of x tall.
G of x
Over
minus
here, it's g of x tall.
1 minus.
How did you get one?
1
I
minus.
mean, F of one.
Wait,
What are you talking about?
I don't know. Who are you?
Okay, so what do we know about this?
Are you doing this?
That was 81. No, we're doing this.
Okay, so we're going down this line, y equals 1 that's up here.
We all along the white line.
So y equals 1 that's up here, then you get the region down here. When you spin, what are you getting?
It's G of x minus.
You're getting a hollow
So
object.
bottom line is that.
Big R squared minus little r squared.
No, you don't do bottom none of what is right minus left.
No, when you do it along the y-axis.
We are doing it along the y-axis.
Alright, Kristen, I got
The
it.
y-axis.
No, I'm pretty sure it's the x-axis.
You are right.
I know.
Alright, friends, let's take a gander. Let's see what we got here.
I'm confused.
Really, wrong,
Yeah.
really wrong problem. Really excited to see how well things going for us here with all the geometry. Alright, part B, we already talked about part C. Right, we've got two different integrals, pi integral 0 to a f of x squared dx plus pi integral a to 1 g of x squared dx. That might be a 2 or 3 point question in the free response. How many guys are like, this is under control? Like, this is good. All right. Part E is definitely meant to be a challenge. So let's talk through part E together, whole group, and then we're going to move over to a journal entry, and you're going to get some individual practice time. Part E, if you, oh, mother of God. If you're feeling good about part E, keep going to part F. Okay, where are the folks that are with me on part E? Okay, most of the friends. Okay, important questions to be asking yourself. What are the questions? What are the things? One, hollow or solid. Even before that, I'm going to ask, where's the axis of rotation? Y equals 1, which is where? Okay, I'm so glad that you guys know. There it is. Y equals 1. This is the region. The important thing to ask yourself now, Mariah.
Oh, it's not hollow or solid?
Hollow or solid? Or like I did to the AB kids last year and somebody was here observing, I kept asking them solid or hollow. They were like, I don't know either word. And I kept doing it and the observer was like, I don't understand what you're talking about. I'm like, no one does. I'm making up words. The question is hollow or solid, and the answer is hollow. As soon as you know hollow, here's what I hope you do. You're like, oh, hollow. Volume equals pi, integrate something, big R squared, dx or dy?
V1. No.
Dx or dy?
Okay. But it's
If you're spinning around y equals 1, you're going to take this guy here, reflect it up. Oh, so awkward. Totally not drawn. I can't do that. Totally not drawn to scale. You're going to draw your little rectangle. You're going to draw the little reflection. Wow, so bad. Mrs. Blakely at East End makes that look so good. Not me, though. Dx or dy?
DX.
Rectangles are going this way. Dx or dy?
DX.
It has to be dx. So pi integral big R squared dx minus pi integral little r squared dx. Great. Here's the tough part. What's big R? How do I find big R?
Oh, it's 1 minus g of x. 'Cause
Okay, so Edgar, I hear you say 1 minus g of x. So are you thinking that this is big R?
yes.
Okay, so big R, you're going to say big R is 1 minus g of x. Last class, some folks said, no, that's not big R. Here's big R. And those folks said big R is g of x minus 1. You start on the axis of rotation. For your radius, you start on the axis and you go till you get to the outside curve. How long is that slice? G of x minus 1. So when I do my setup, I'm going to say pi integral g of x minus 1 squared dx. Jasmine, not you Jasmine, my other Jasmine. Jasmine had this. And oh, the conversations we had. Who's right?
Jasmine.
When in doubt, Jasmine's right. Are these the same?
No.
Oh, yes.
It's a reflection. It's the same.
No, same.
Okay, how many of you guys think they're the same? That they have the same value? How many of you guys think they have different value? Okay, Nora, why do you think they're different?
Because it's like you're doing 1 minus g of x.
Yep.
I feel like that makes g of x like not a.
So you see 1 minus g and you're like, that is different than g minus 1.
No.
But you're convinced that these are the same. Why?
Because it's squared.
So what? You're right. So what?
Like if you multiply a negative by a negative, it's going to be, a positive.
Right? Think numbers. Easy numbers. 10 minus 1? 9 squared. 81. 1 minus 10? Negative 9. Square it. 81. So who's right? Both. It is just a matter of your interpretation. Are you starting on the axis and going down to that outer curve? Or are you starting on the axis and going up to the outer curve? Both are the same. We're good? All right, so then the next part should be easy. What's little r? 1 minus f of x minus 1 doesn't matter to me. Square it, dx. Limits of integration? We're going from, what is it, a to 1? A to 1. 1, what's up? Jennifer?
How did you get that minus, like why?
Why the minus 1? Good question. You are starting on your axis of rotation and you're dropping down till you hit the outer curve. Top minus bottom is the way that we measure length. 1 minus, or that function minus 1. Everybody okay? All right, good. So, perfect time. We've got 30 minutes. That's what I was hoping for. I want to give you guys a little taste of the quiz in a non-threatening way. For the next 6 minutes, with no help from your partner, it is just you and your calculator. The goal is to get through A and B, and for my super smarties, push on and get to part C.
So just A and B?
We're going to do the whole thing over the course of the next 30 minutes, but A and B is going to give you a good sense of how ready are you for tomorrow. What's different about this problem?
Goes to us.
Like compared to the last one that we just did? I gave you functions. What else is different? No picture. You've got to be ready for both things. The tough part here might be, once you get the graph, making sure you know what region you're looking at. If you're unsure at all about the region, just call me over and I'll say, yep, David, that's the right region. Just, you know, in case, David, that comes up. David, how do you feel about driving the laptop? No, that's not it. Okay, I can tell by the face. Eunice, how do you feel about driving the laptop? Eunice is like, there's no Eunice here. Anybody want to drive the laptop? Because you're new to the Inspire, not you. Yeah, Nora, let's get you over there. Sorry, Jasmine, but... Christian, stop cheating. Everyone's going totally on their own for right now.
doesn't say it's above the function. It's bounded above by the function, meaning that the function is like the ceiling. Yeah.
Part A is going to be worth 3 whole points. Part B is going to be worth 3 points. About 1 minute left. If you're already done with A and B, keep going. Don't let me slow you down. You're killing me. Oh my God, you're killing me.
Should I try harder?
I mean, that would be nice.
How many decimals?
On any problem I'm never gonna ask you about.
I don't even know why it's
Okay. These things happen. All right, so real quick, A and B, I don't even think I need to explain anything, it went so well. So here's the region, here's the graph, here's the function, looks something like that. Here's f of x, here's g of x. This is the region. A lot of folks instinctively said, here's A, and A is what, like 1.102? Okay. Curious, is everybody 100% on the like storing and using it later?
No.
No? Make sure before you leave here today we talk about that, because that storing and using it later makes your life so much better. So much better on all the things. Okay, part A is going to be an integral from 0 to a, f of x minus g of x dx. Depending on how the College Board sets up the rubric, they might say, here's a point for getting the limits of integration. Here's a point for having the right integrand, and then a point if you can tell me what the final number is. And the final number is, I've got 1.763535. The OCD takes control. I like 6 decimal places. I need 3. So right answers would look like 1.763. Right answers also look like 1.764. Either way, 3 points. How many guys honestly would have just picked up all 3 points? Good. This is what should happen. This should be a good, happy experience. B, Juan, tell me, what are your thoughts here with part B? Find the volume R is revolved around the x-axis.
It needs to have pi.
Okay. So volume, we're doing something with pi.
Then an integral from 0 to a.
0 to a.
F of x squared. Parentheses dx times dx.
Okay, times that, yeah.
Minus pi times integral from 0 to a.
0 to a.
G of x squared dx.
Okay, how many guys honestly have that as your setup? That's got to be worth at least 2 points. I will tell you though, before I reveal the number, because you were all here today, let me tell you what's going to happen tomorrow on the quiz. Make sure you hear this part. Multiple choice part of the quiz, I might ask you, what is the setup that you would use? Not what is the answer, but what's the setup? And here's how I might write the answer. Anybody know other ways you could write the same thing? Legal things. What are those tricky things I always do to hide things from you? Noemi.
To just like pi times the integral of 0 to a.
Okay, pi times the integral from 0 to a.
And fx squared
Yep.
minus g of x squared
Oh man, you're going like all in.
times dx.
Times dx. You went big. Same thing?
Yes.
Right, 2 things that you did. I thought you were going to do one. You did both at the same time. You factored out the pi, which is okay. And then you went from 2 integrals to 1 integral. And that's okay because we're saying integral from 0 to a, integral from 0 to a, 1 integral, 2 integrals, same thing. Everybody good? Okay, so here's what the answer could be. You might choose to write your answer this way, 9.695 pi. Or you might choose to write your answer as 30.459. I bet most of you have 30.459.
Yes.
Did anybody do 9.695 pi? What's this kid doing? Jasmine, what are they doing? They're not multiplying by pi. What they're saying is, let me do this integration over here, and then just remember to multiply by pi at the end. Totally legal. Totally legal stuff. Everybody's good? So I would say 1 point probably awarded for remembering the pi and getting your limits of integration. Another point for the integrand. Another point for that. Between A and B, how many guys would have gotten 6 points? Where am I 5 points out of 6? I can deal with 5 points out of 6, 6 points out of 6. All right, good. Let's push a little bit further. Part C, find somebody that you're going to work with. You've got 3 minutes. Part C is a 3-point question. I'm curious to see what you can do.
I don't think I got them.
I don't know how to change
It's like absolutely
Oh, it's not. I thought it said
The y-axis doesn't say that.
I mean, didn't he do it like if it was solid?
Isn't the same thing?
Oh, okay.
Right, big R squared minus little r squared.
Oh, okay. Okay. Wait,
It's the same thing like me. Use factor 6.
It does subtract 2. Or is either way?
Yeah, it's not
I think
a
what
Yeah.
you're thinking about is y equals 6 means
But
shifting
isn't it
everything up
GMS?
6 spaces.
Because look, I did it.
Putting
I
the
did it
axis
with the
of
first
rotation
one,
on y
the
equals
FX
6
first, and then I got negative
draw
1.
your axis of rotation up here above the graph and spin around that.
So why?
Switching.
Yep.
So it's F2 first. And then
wait, isn't it hollow if the thing of rotation is the x-axis?
Yeah.
So then, okay, so we know that it's f of x minus g of x, but that's just that's just r.
You're on a break.
I don't know how to say it in words.
Come on.
Okay, so this is r, right? That's f of
Wait,
x minus
what's r?
this.
No, that's the problem. When we're talking about the radius, you're measuring from your axis of rotation. Where's the axis? From here up to, up to the outside curve. And then little r goes from the axis to the inside curve.
Okay.
Right, and so your setup for a hollow object is always going to be pi integral big R squared dx, or maybe dy, minus pi integral little r squared dx, or maybe dy. But this is definitely hollow because this region here doesn't touch the x-axis. Okay.
You're seeing these functions? Basically,
You ready?
the axis is the outer one, to the inner one.
That's what I was saying.
Okay.
I know what I was saying, like, don't you act,
no, it's just down.
But you're not adding to them. Because here's the line y equals 6, and like here's the function. The radius is the distance between them.
so you're
You just subtracted by 6, right?
Alright. Alright, let's check in about 30 more seconds on this one. If anybody is feeling pressed for time, know that most of the points come from the setup, even if you can't type it into the calculator well.
Why is it 3 so far away?
Whoa.
3 so far away.
All right, friends, I'm feeling good about all the things I'm seeing, so if we can stop for a second. Here's y equals 6. That's what I'm revolving around. Easy question, hollow or solid?
Hello.
Hollow, right? So now big R, I need to get rid of this because it's a different axis of rotation. That was not me farting, that was me erasing with the finger. Trust me. Those are different. For my friends who are just like, I don't get the big R and the little r thing, you always start at the axis of rotation. Here's my axis of rotation. Big R, when do I stop?
0.
All the way down here? I stop right here. I go from the axis to the outer curve. How long is big R? 6 minus g of x, or my friends that say g of x minus 6, same thing because of the square. David, how long is little r? Little r, 6 minus f of x. Nora, have you had a chance to type in the integral and do all the things? You're just enjoying the comfortable chair back there? Okay. Volume equals pi integral big R squared dx minus pi integral little r squared dx. 6 minus g of x squared.
Tab. Tab.
Control and the left one.
Wait, is it? I just tab.
She's a new driver.
You crash.
Oh God, what are you doing?
Don't you need to
Is
take
it
a
control?
test?
Yeah, get out of there, get out of there. Get escape.
No, you get that.
Okay, click on this one. Okay, click on it again. There you go. Okay, so pi, we're going to integrate from 0 to a. 0 to a. 6 minus all that squared minus pi. Oh!
Oh.
Nora, hold on 1 second. So Nora's got negative 36.02 something. How many of y'all just know it's wrong? Like, it has to be wrong. Adriana, why does it have to be wrong?
Because an object, a 3D object can have negative volume.
Can't have negative volume. Cannot possibly have negative volume. Anybody see the mistake?
F1 and F2 have been switched.
The issue is F1 is f of x, F2 is g of x. What? That's not yours. Okay, well anyway. The right answer should be 36.027.
Wait, can you explain that again?
What's happening is, and I'll figure out what's going on there, Nora, in just a second. I think whenever these were typed in before, the F1 and the F2 I think have switched. So it should be 6 minus F2 of x squared, 6 minus F1 of x, the whole thing squared. Here's the thing, if tomorrow in the middle of the test you get a negative volume or a negative area, clearly something is wrong, pick the positive version. Okay, everybody good? All right, good, time for push. All right, go for it. Part D. I just want to see what I can do to your brains. Would that be legal? That's what I wanted to hear. Let me get to Jasmine, then Daisy. Jasmine. Okay, hi, story.
Is it still from 0 to a? No, right? It's from.
Yeah.
Don't tell me. Don't tell me.
Not just
Isn't it from right to left?
so for the go over, like you have to switch the variable.
So it's like 1?
Once.
No, sorry. Hold on. No. It's a number.
One time on the once. It's highlighted now. Yeah, it is.
Found it.
Which one?
When do we do this? When do we do that?
Oh, yeah.
Do we do those things?
I don't know what's up.
You. Oh, okay, yeah. And then to that intersection, right?
I saw this.
You're back! I got changing. I got life changing. Excellent.
So it's from 1 to B, right?
Evil. Here you go. One of those is to get and the rules there are.
If you want to take the class, just put a yes. So we're gonna write
What?
down.
And you can use your calculator just divide by
Not
Not even, I mean, you want to talk to your mom about it, that's okay. Remember, your mom's a math professor.
Oh my God,
We're gonna have some problems.
So this one is at 4, right?
I think I'm sick, but I'm
And
not
if you
sure.
guys could leave the homework assignment with me, that would be good. Abraham.
Yeah, Abraham. You're welcome.
Start.
I told you.
And then it just g of x minus y?
like you have to like figure
Did you find the intersection?
Julie, in the words of my daughter, amazeballs. This is amazeballs. The number of people that are not falling for my tricks this year. We're on part D, right? Okay. Jose?
I know.
Jose, what's the trick I thought everybody was gonna fall for?
That we're doing here.
Wait, what?
I don't know what you mean by square.
Okay, part D, what's the axis of rotation?
Y-axis.
Y-axis. There's my y-axis. As soon as you know that you're revolving that way, which way do the rectangles go?
Horizontal.
Right to left.
They go this way, so already you need to be thinking,
DY.
DY. Your slices go this way. Okay, good. So it's a dy. I'll tell you, as soon as I see, now let's see, hollow or solid?
Solid.
Are these questions like really starting to help like gel everything together? Great. Solid object spinning this way, dy. Got it, dy. I have seen on so many papers, pi. Something's gonna get squared, dy. Great. What's gonna get squared?
The right.
It's gonna be
Right, I've got to figure out how long's the rectangle. David, how long's the rectangle?
It's the function, but you have to switch to x and y.
Love it. Right, the length of this rectangle, we're going to do right minus left. Great, which one's on the right?
well, that is 2.
It depends.
It depends.
The answer is, it depends. Which one's on the right?
Which one do we want?
It depends, am I down here or am I up here? So what you have to do is think about it in like 2 different regions. So I'd say like there's like volume number 1 down here, and then there's like volume number 2 up here. Because the way I determine the length of the slice changed on me from down here to up here. I think we're okay? All right, so important things now. Limits of integration.
Which one do we want to do first?
Let's do the first one. So like volume 1.
Oh, okay. It's from 1 to B. 1 to B.
1 to B, yeah.
1 to B.
1 to B.
No, because it's y-axis.
Right? If it's dy, your whole world changes. Everything changes on you. You're not going to go from 0 to A anymore. You're going to go, this is the point 0, 1, and this guy up here is the point A, B. So we're going to go from y equals 1 to y equals b. On the next integral for volume number 2, I'm going to say, oh, I'm going to go from,
B
what is this,
to-
y equals b to this guy over here, y equals 4, something's going to get squared dy. What's getting squared?
I don't know how to do this. The sign.
Right, if, what are we on, the bottom part here? Is this g down here?
Yeah.
Right, so this guy here is going to be in terms of g, but for g it says y equals 1 plus 2 sine of x. I need a dy, everything in terms of y. Easy stuff here, right? Y minus 1 divided by 2 equals sine of x. Gosh, if I only knew how to get rid of the sine.
Arc sine.
Arc sine. Arc sine. Last year in pre-calculus is where you guys learned about arc sine. I was there, I watched.
I don't think I was there.
Oh, it must have been that day, yeah.
Yeah.
But I know Christian was there, because Christian has perfect attendance. Arc sine y minus 1 over 2, the whole thing squared dy. This guy here should be an easy one, is it?
Square root of 4 minus y.
Square root of 4 minus 1? Square root of y minus 4? Oh, that would make a difference. Okay, let me see. So y is 4 minus x squared. Y minus 4 is the negative of x squared. So negative y plus 4 equals x squared. X is the square root of negative y plus 4.
So it is 4.
Or 4 minus y.
Yeah.
I'm not interested in anybody type this in the calculator. What I am interested in these last couple of minutes, see what you can do with part E. We've only got 2 little minutes left. Thank you. All right. Nora, thank you. Jose, you okay?
Yeah.
You sure?
Oh, yeah.
But the things are gonna be like this.
X equals negative 3. So if here's your region, you're over here. This is your axis of rotation. It's going to be a dy angle for sure. For sure. Ah, bummer. It's 409. As much as I would love to keep some of you forever. Okay. Yeah, so Steven Spielberg, we can turn it off. Thank y'all very much. Tonight's